Lesson 29 Lifecycle of Reactive Effects. 1. Introduction. Good morning, afternoon everyone. Today we'll explore how reactive effects work in React. We'll focus on how they differ from component lifecycle, how they're managed, and why understanding them is crucial in building robust React applications. 2. The lifecycle of an effect. In React, components have a well-known lifecycle. They mount, when they appear on screen, update, when their props or state change, and unmount, when they go away. But effects, the pieces of logic that synchronize with external systems or carry out side operations, have a different way of behaving. An effect doesn't necessarily map one-to-one with a component's lifecycle. Instead, each effect describes how to start synchronizing something and how to stop synchronizing it. That start-stop cycle might happen multiple times while a component remains mounted. 3. Why synchronization may need to happen more than once. Imagine a component that connects to an external system based on some prop value. When the prop changes, the effect must tear down the old connection and establish a new one. So even while the component is mounted, the effect might go through several cycles of disconnecting and reconnecting. The reason is, the underlying data that drives the effect changed, and so the effect must respond and keep things in sync. 4. How React resynchronizes your effect. When React notices that one of the dependencies of your effect has changed, it does two things in sequence. First, it runs the cleanup logic from the previous synchronization, stopping whatever was running. Then it runs the effect body again, setting up the new version. This ensures that the external system your effect depends on is correctly aligned with the current values of props or state. 5. Thinking from the effect's perspective. It's helpful to shift our mindset. Instead of thinking, what does this effect do when the component mounts, updates or unmounts? It's better to think, what does this effect do? How does it start? How does it stop? Each time it needs to. This way you treat each effect as its own independent process of synchronization, rather than forcing it into the component lifecycle framework. 6. Each effect represents a separate synchronization process. One of the common mistakes is to lump multiple unrelated tasks into a single effect just because they loosely occur at the same moment. A better approach is, if two things are truly separate, for example, one task connects to a server, another tracks a page view, then use two separate effects. Keeping them separate improves clarity and maintenance. Conversely, splitting tightly coupled logic across multiple effects can make things harder to follow. 7. Effects, react to reactive values. In React, reactive values are props, state, or other values derived during rendering, for example variables calculated from props or context. If your effect code reads such values, then changes to those values should cause your effect to resynchronize. That means they should go into the dependency list of the effect. Non-reactive values, for example values that never change, or external mutable state not managed by React, don't belong in that list. 8. What an effect with empty dependencies means. If an effect has no dependencies, an empty list, it means start once when the component mounts, and stop once when it unmounts, and do not restart when props or state change. That's appropriate when the code inside the effect doesn't depend on any reactive values from rendering. But if it does depend on something that may change, then you must include that dependency, or else your effect may become stale or detached. 9. All variables declared in the component body are reactive. Values declared inside the component body, whether state, props, derived variables, context values, all of them may change on a re-render. Because of this, if your effect reads any of them, you must treat them as reactive and include them properly. Ignoring this leads to subtle bugs. Your effect may continue to reference old values and remain out of sync. 10. React verifies that you specified every reactive value as a dependency. React's linter tools will check your effects and warn you when you've omitted dependencies that appear necessary based on the variables you've read. These warnings represent legitimate issues. Your effect may not resynchronize when required, or it may resynchronize too much. You should not simply ignore or suppress the linter. Instead, you should understand the root cause and adjust your code so everything is consistent. 11. What to do when you don't want to resynchronize. Sometimes you read a value inside an effect, but you don't want the effect to rerun when that value changes. In those cases, you have two choices. Restructure the code so that the value is not treated as reactive, for example, move it out of the render path, or mark it stable, or restructure the effect so that part of the logic is decoupled. Avoid permanently suppressing linter warnings, because they indicate a mismatch between your code and React's synchronization model. 12. Recap. Let's summarize. Components can mount, update, and unmount, but effects have their own lifecycle. Each effect describes how to start and stop synchronization. We must think of each effect independently. We must include all reactive values in its dependencies. We must use separate effects when tasks are distinct. And we must heed linter warnings to prevent errors in synchronization. 13. Closing remarks. Whenever you write an effect, pause and ask, what am I synchronizing here? What values does this synchronization depend on? How will I stop it when things change or when the component is removed? By thinking in those terms, you'll write effects that are robust, maintainable, and aligned with React's rendering and reconciliation process.